In 3.6, we're going to take a look at problem solving, but using systems now. So we've done problem solving with distance rate problems with the first chapter. We did them with inequalities, where we had a range of answers. Remember, like the person's grade could be a B, and a B was from 83 to 87. Determine the possible score of the first test, and you were given other information. So we were given those word problems with inequalities. Now we'll look at word problems that have more than one equation. So either two equations with two variables, like we've been solving, or three equations with three variables. The three equation, three variable ones, I really encourage you on the test to use your matrix. Please don't do it by hand. Is that clear? Okay, I'm going to give you a quiz on a three variable one, but I'm not going to put it on the test because it can become like a 10-minute problem sometimes, and it's a test killer. You get one little part wrong and you're done for the rest of the test. So I'm going to put a three variable, three equation system on a quiz for you coming up. Okay, keep that in mind. But on the test, I'm going to limit it to two variables. When you do have three variables and three equations in a word problem, I want you to use your matrix to solve it. So I'm telling you now that there will be a word problem with three equations, three variables. Use a matrix on the calculator to solve it. Don't do it by hand. So let's apply it to some word problems. So let's take a look at a very simple one first. Please use let statements. Please use let statements. Some of you are very disorganized, and you see I write that on your test. I'm like, where are you writing? You're going in circles. There's no organizational skills. So you start first with a let statement at the top to make it look neat. So what are we going to make a let statement here? Remember, the let statement answers the question. What's the question? You could all read, so you can read the question. I know a lot of you are jumping ahead and love to do it ahead. I can see it right here. All right, do it ahead for a minute. I'll give you another second. I can literally see a lot of you already writing down the work to do this. So I'll give you a minute to look at it. Okay, but again, I'll put up the let statement. So think about what the let statement should be. The let statement answers the question. And please, you can abbreviate things as long as it's common sense. Like what I'm writing now, does that make sense to you, what I'm writing? Amount of money, amount of money. Okay, or you can even put Sam's money. Sam and then a dollar sign if you want to. That's fine. Write your equations based on what you see. So you're going to want two equations here. Okay, please, I know it doesn't really take two equations. You can combine them and you will. But please write two equations separately for now. You're given two statements, so from those two statements, come up with two equations. How about this first one here? What do you got for what I've highlighted? Kate? So that would tell me that if I take the amount of money that Sam has and add 17 to it, I get what Jim has. So Jim has more than Sam, that means. And I look up and I see Jim has 17 more than Sam. That's exactly right. More than means what? More than? More than? More than? More than? Sounds like I'm talking from the Lord of the Rings. More than? Yeah. Greater than? No. What does more than mean mathematically in the equation? Thank you. Plus, adding. Similarly. So, more than means plus. What would it mean to do multiplication? What would you have to see written to see multiplication?
Like twice or three times as much.
Twice, thrice. Thrice is a word too, actually. Yeah, you know what uses it though. So, yeah, three times as much. You could say quadrupled. Okay, those words mean multiplied by a certain amount. They have $73 together. Tristan, what do you got for this one, please?
I got Jim has, I think I put 28 or no.
The question is, how do I write this? Come on, focus here.
Oh, how do I write that?
Right here, this one.
Oh, okay. J plus 17. Or,
Give me the general statement for now.
J plus Sam equals 73.
Good. And I'm starting slow, guys. I know a lot of you jumped the gun and already substituted, and that's fine. So then wherever you see J, you plug in S plus 17. That goes in right here in the second one, and you solve. What do you get? What do you get, Annette?
The answer or
The answer.
28.
28 for?
Sam.
Sam? And how much for Jim?
And for Jim,
43?
45.
45. together making 73. Again, how do you solve the system? Take one, plug it in the other. Take one, plug it in the other, and solve. You've done this already in the last section, so I'm not going to go through every single step. If you don't get the answer, please ask a question, though. If you're not getting what we're getting, or if you get stuck and you're not sure what to do, either ask or let me know. But I'm not going to go over how to do everything every time, right? Okay. So the next one, again, all we're doing is trying to come up with let statements and equations. After that, the math is easy. You guys are good at this, and you can check on your calculator. Either with the graphing, finding the intersection, if it's two variables, or a matrix with two variables, either one. And with three variables, though, you got to use a matrix to check. Or you plug it back into the system, obviously, to check. This is an interesting one. Try this on your own for a minute. This is tough. I want to see who can think outside the box here. This is not one that's easy to write out. And then once you write it out, you'll see it's very easy to solve. Like it's extremely easy to solve. Take a minute to look at it.
Look, I've done this exact problem before.
You feel like you've done this exact problem?
Yeah. Maybe last year.
Think about when you're on the train and the train's going forward and you're also going forward. Okay? Or if the train's going forward and you're going backward. Right? Think about what velocity, what happens to your velocity at those instances. And then apply it to this. Can we define jet stream for those who may not know what the word jet stream means? Somebody define jet stream?
It's the wind that's like coming against the plane that slows it down.
Yeah, the wind, the air, the way the air is flowing. So the air is either flowing against the plane or with the plane. It helps the plane or it hurts the plane. Does that make sense? There's always a jet stream in the air. Well, at least, no, I shouldn't say always. In this case, they happen to be against and with. Can somebody give me let statements first to start? The question is, what was the jet speed in still air and the wind speed of the jet stream? That's how fast the air is going, and that's how fast the plane is going. The word jet is there twice. Do you see how annoying that is? And I left that. So I pulled this example out of an old textbook I have, right? And I'm looking at this and getting the idea and realizing jet and jet stream are annoying. But on these SATs, this is the kind of stuff that they do. They somehow involve reading comprehension and math and make it like you have to like confuse the two variables. What do you got?
Let the first trig equal to 600 miles per hour and the second trig equal to 400.
Okay, so you're giving me velocity off the bat? So that's true, but I asked what are the let statements, right? That was my question. Those weren't the answers to let statements. What are the let statements here?
Let x equals to the speed of the air.
Speed of the air?
Yeah.
Okay.
And let y equals to the speed of jet stream.
Well, jet stream and air are the same thing.
Oh,
So
in the first one's these, the speed is
The plane.
The plane.
Yeah, sorry. So that's why I was saying this might be confusing. So the word jet is another word for plane. But jet stream is air flowing. Is that weird? It's not, they're not both airplanes. One is the air flowing and one is actually an airplane. So yeah. We're looking for these two things, right? So George, you gave me answers already for velocity, which is what we're going to use in a moment. It's going to come up. But could somebody give me an equation to use here? Can you give me an equation to use? An equation. What's the general equation we use here that relates velocity, distance, time? What is the one we're using?
We're using speed.
Okay.
X plus y equals to 600.
Okay. But the general equation. Just let me ask you for the general equation first, just so we can go one step. Speed is equal to what over what?
Speed is equal to x plus y.
Over?
No, distance over time.
Yeah, that's all I was asking for now. I get what you're doing already. So what I want to think about is this. The speed in one direction involves what? And then in the other direction involves what?
When they're going to, it's x plus y.
Okay.
It's come back to x minus y.
Yeah, so yx plus y. What is the plus y and minus y? What's happening there? Physically, what's happening? I'm asking you the physical nature of the problem, not the mathematical. Physically.
Either you have the wind at your back or like pushing against you.
Yeah, the wind is helping you, and your velocity is x plus y. The wind is hurting you, and your velocity is, your velocity is x plus y, but when it's hurting you, it's y minus x, based on what you wrote, right? Y minus x for the way back, because it's the jet, meaning the plane, minus the air. So in this case, we're going to write our equations out here. So we've got our speed here, we're going to have x plus y, and this distance is still 1800. And when the speed is with you, and when the air is with you, doesn't it take less time? Isn't it helping you? So that's the number that was less. That was 3 hours. And then when it's hurting you, it takes 4 hours. So George came up with these values of 600 and 450, and that's exactly right. That's where he got these from, but that's what they're equal to. So now we have a system. What's the easy way to solve this system? That's why I was saying it's so simple to solve. What do? Just add them together. Add this equation to this equation. The x's cancel. You're left with just simply 2y. And this is 600 plus 450 is 1050. 2y is 1050. Y is 525. And then what does that make the other one? 25 or something, or 75? 75. It was one of the two. Okay, so 525 for the actual jet. So that's going to be y. Y turns out to be 525, and x will turn out to be simply 75. Okay, and just sum those together. An exam is worth 145 points, contains 50 questions. Some of the questions are worth 2, some of the questions are worth 5. How many 2-point questions are on the test? How many 5-point questions are on the test? How many of each? I should have just said questions are on the test. So we need let statements to start always. X and Y don't have to be what's used, but I'm going to use them just for the sake of it. X is? Come on, quick, answer the question. X is. This should be easy, right? Number of? Number of 2-pointers. And number of 5-pointers. There are 50 questions total. That's so easy. So what do I say? Right off the top, bridge. 50 questions.
X plus y equals 50.
Yeah. Nicely done. And the second part, Annette, how about that one? The exam is worth 145 points. How do I allot points here?
Well, since you have, it would be like 2x plus 5, y equals 145.
Good. 2 points per question times x questions. I'm doing this on purpose. I'm putting units so you can see the units make sense. And then 5 points per question times y questions. And that equals 145 points. Look at the units, please. Everybody, pause what you're doing. This is a great skill to have. You'll use this in physics later. Please look up. Look what happens to the units in this problem. The number of questions cancels in both cases. So this is 2 points per question times x questions. Questions cancel here and here. So the units are points. If the units are points on the left-hand side, the units have to be on the right, and they are. And this has to be the same units. To add 2 numbers, they have to have the same units. So always use your dimensions to help you. I'm telling you this because this is an easy question, and it's easy to show you why right here. But you're going to have questions later that you're not going to know what numbers to use where. And they're going to be a little bit trickier. Okay?
So 7x equals,
So we got 2x plus 5y equals 145 as the equation. So solve these equations together. I would use elimination again. I would multiply the first equation by -2 and then add it to the second equation. Or substitution, honestly, it doesn't matter. Whatever you find is easier for you. How about this one? Let statements, set it up on your own. Give you 1 minute. That's all you need for this. Literally, 1 minute is all you need. And this could be a question on an SAT that only takes about a minute to do. It's right in the medium to difficult section of the SAT, just because of the number of variables. What's the fastest way to solve this? Use a.
Two equations together.
You can combine two equations. You could, but I would go right to a matrix for this personally. I had to rewrite this last line. Reorder it as, let's see, we want k and b on the same side, so negative b plus k equals 4. And then I write my matrix as 1, 1, 1, 70, 1, 1, 0, 39, 0, negative 1, 1, 4. Make that look nicer. What's another thing you could have done with the second and first equation to make this a little bit quicker on yourself if you don't want to use matrix? George, what did you do?
Well, you could eliminate it. Like,
Tell me.
you can multiply by -1.
Yeah, but there's an easier way actually. Anybody pick up on this? This is kind of weird.
But just to solve the problem or for this, or for
There's a quick way to start this problem and get answers very quick, like very quick.
Just use equation 1 to minus.
Pretty much is what you're saying, but use in the sense of substitution. You could subtract the two and they're going to cancel, right? But what could you also just think of?
You could plug in j plus b. You could plug in 39 for them. And then
Boom. Right? Isn't that what that's what you're doing? Exactly right. Same thing. So eliminate them by subtracting them or adding the opposite. But substitution, if you think of j plus b as 39, just put that in your head, and then get k, then get b, and then you can get j from the second one. What do you end up getting? What do you got?
B is equal to 27, K is 31, and J is equal to 12.
Good. All right, last one. At this point, this should be actually pretty easy for you. Now, all these problems are similar in nature, the setup of them. The concept is that you understand linear algebra, so later on with calculus, you could actually use this.
Let's see.
How many equations? Just answer me that. How many equations? Thank you. How many variables, obviously? Okay. Again, by hand or matrix, either one's fine. There we go. Hand calculator, fine. What do we get? Cost of a burger. Cost of a burger. Fries? Shake? Yeah, that's ridiculous. The shake is not two. I totally screwed that one up, didn't I? I'm thinking about it now when I pick these numbers. You know why? I used to use in my example. How many of you have been to, what is it called? I haven't been there forever. No, they have like Checkers. To say they have checkered fries. You been to Checkers before? Have you had the banana milkshake? They make a banana milkshake. It's off the hook. It's so good. So, but their shakes, they're cheap. They're like $2. So anyway, I used to use this and I used to use Checkers. I taught in a school where there was a Checkers nearby. When I grew up, there was a Checkers when I knew. But now when I moved to the city, I was like, no, in the first year, none of the students knew Checkers. So what did I do? I changed it to Shake Shack, but what did I not do? Fix the numbers, clearly. This is not Shake Shack prices, right? Shake Shack's got to be more than this. I was talking about an example.